All right. All right. So today we are going to discuss something called Apache Spark. Okay. Apache Spark is the latest invention, latest product, which helps you churning the data really, really fast. So it tries to utilize your memory, it tries to utilize your memory as much as it can, and then give you the results. Okay. So when it when most of the map reduce is in the memory, it's close to 100 times faster and than Hadoop and 10 times faster than when it's doing it in disk. So 10 times faster is a really really good number. So you can in general say that Apache Spark is really faster, and it also builds on a similar paradigm as Hadoop. Okay, and it is very well integrated with Hadoop. So today, unlike our previous sessions, in today's session we are going to have the demo of Spark as well. I have installed Spark on one of the nodes, Hadoop one, and that is integrated with our rest of the cloud labs. Okay. So and it utilizes the Yarn framework in our case and provides you the whole infrastructure. Okay. So this is the first class in which we are going to give a demo of Spark, although it is like highly packed schedule, but we will try to explore Spark as much as we can. Okay. Now, Spark is a really, really good solution and is a complete system. So just like Hadoop, it basically has multiple component, and Spark core has is dependent on either Mesos, Yarn and Mesos is something which do the distributed computing execution of Spark, while standalone scheduler is something which can also be used to run Spark. Okay, so either of the three you can use to run Spark. So right now the one which we have is Cloud Lab based Yarn, the Hadoop 2.0. On top of that, we are running our Spark. And once you have Spark in place, you have machine learning library provided with the Spark, and apparently it's pretty good, better than Hadoop, but better than Mahat. And GraphX is a graph processing library which does a lot of cool stuff for you. And similar to Hive, we have Spark SQL here, and Spark streaming is also present because Spark is a really fast system, so it was possible to build a streaming solution on top of Spark. Okay, so these are the various things, various other components other than the core Spark. These are the four other components which are based on top of it. So we'll be basically exploring two components out of it. One is Spark core. We'll be diving a bit deep, and then we will be discussing quickly Spark streaming. We'll not be touching MLlib and GraphX or Spark SQL right now. Okay. Why? Because machine learning, one example we have covered from Mahat, and graph processing is little beyond the scope. While similar to Hive SQL, Spark SQL is there, so you would not face much of a difficulty. But since we haven't covered streaming example so far, I want to cover streaming example once. All right. So, in very simple words, Spark comes with four things to us. One is core Spark, on which you program, and using these machine learning libraries, they basically are libraries which run on Spark, and so on. All right. So, are you guys with me? Okay. So keep asking questions. As in when the question comes to you, you should just type the question and then we carry on. Okay, so this is general overview. Now, those who want to set up their own installation, okay, a better would be that you go to Spark downloads and download one for Yarn. If you have set up already set up your cluster, then all you have to do is download this particular file, extract it, and here I have put a RM, which means it also deletes the actual TGZ. Now, after you have extracted this file, you just move it to user lib, then create a link. So basically, all I'm trying to say here is all it does is download this file, open it, and then start it. That's all. That's all you need to do. Rest is just just the management points. So all you need to do is download this file, unzip it, and then run this particular command in order to run Python Spark. Okay, so for us, this is all set up on Hadoop 1 right now. So you do not have to do all of this installation, the first part of it. Okay, what happened to my, okay. So you do not have to install any of this. All you have to do is log in as a student into Hadoop 1 and then start this. All right. So let me just open it up, and so my screen is visible to all of you. So all I did was SSH into Hadoop 1 as a student. It'll ask me to enter the login. Okay. So we have this. So let me just copy paste this command, and there we go. So we are all running. So Spark is installed into the folder called userlib. So everything is in place. Now we are running Spark. We are running version 1.1 right now, and although 1.2 has been released. Okay. Now, great. So we have our Spark running, and I'm using, there are two or three commands. One is in Scala, other is in Python, and the third one is similar to Hadoop jar. There is a submit job in which you compile your Java code and then upload it. Okay, I'm not going to do that. I'm going to use the command line version. So for the interactivity, okay, I'm sure most of you will be able to understand of uh, the code of Python, because it's pretty simple. If it is not, in case, even if you have never used Python before, you should be able to understand. If not, just raise your hand and I'll try to explain each part. All right. So first point is that do not panic. It is going to be a little fast ride, and you keep asking questions. All right. Cletus, are you okay? So, all right. So this is how. All right. So everybody okay? So should I start and jump into Spark now? I'm just checking whether you're listening to me. All right. Now, great. Vishal, Virana, Srivasant, Siva, and I don't know who is HTML5 viewer user. All right. So everybody in? Great. Now, so a little bit of concepts first. Little bit of concepts. So the the core concept in Spark is resilience distributed data set. Okay, a resilient distributed data set is basically a memory So there was no question. I was just asking if I should start or not. All right. So resilience distributed data set is the main concept around which the whole system revolves. All right. Just give me a second. I need to turn off my phone. All right. So we have got a data set which is uniformly accessible to all the programs. Okay. It's basically a representation to your code, okay, on which your code will be running. So resilience database is basically a sort of a mapping between the actual data and and, and a representation to your code. Okay. So resilience database data set can be created on anything. Whether your data is in memory, you want to create an RDD on top of it. It's like a uh, abstraction layer on top of your actual data. Abstraction layer, you understand? That hides your actual operation of distributedness. Your data might be distributed across 100 clusters. It all hides that complexity. Okay. So the way HDFS provides you hides all the complexity of distributedness of the data. We have logs, they are hidden here and there, they're kept on this node, that node, and this replication and all there are this complexities, there are portions. So all of that kind of complexity is hidden by HDFS for you. Okay. Similarly, resilience distributed dataset is basically one very thin layer on top of your HDFS. In case your file does not exist in HDFS, then it creates a similar kind of structure in the memory if your file is located on network file system or somewhere else. All right. And even if your variable is there in the memory, that also you can load it in the resilience as a resilience dataset. So you can load any kind of data into resilience dataset first, right? Second, it can be resilience dataset can be persisted into a memory, meaning whatever resilience dataset generally is a virtual representation of your data, and sometimes instead of computing that again and again, you want to keep it cached. So you generally do it, we say it persist into the memory and it will keep it in memory, right? Just like HDFS, it also recovers from the failures because it also runs on multiple nodes. So while on the, so you will get the hang of it as we operate upon it. So all the operations we do is on the top of RDD, resilience distributed dataset. It can have any data type but has a special dataset type for key value pair. Okay. So resilience dataset is basically a variable which is given to your program, and that variable could be of any type. Okay. Except for key value pair, which is a map. Okay. That's a special data set. Otherwise, it can be of any type. It can be an array, it can be a number, it can be a huge list of maps. So it could be a lot of things. All right. And every resilience data set you understand, right? When you say select a star from something, so generally it gives you a cursor. So cursor is the data set in your traditional SQL, right? Similar to that, resilience dataset is also like a cursor on top of which you execute multiple operations. All right. So and and you can run multiple kind of operations. There are two basic operations you do on top of resilience dataset. One is transformation and action. So when you run a transformation, then your logic is run on multiple machine. When you run an action, the data from all the nodes is gathered to a central point. Okay, so let's start. Let's first create. You remember this file, asgiri word count, and we had this file for our usual word count. Okay, so here I'm loading that file. I'm saying, so this is basically sort of a Python, but the API is same across all. It says that load this HDFS file. This is the file which exists in our HDFS. Load it. We are asking Spark context that this is my text file. Please load it into resilience dataset called lines. Okay. Now we have got lines as the resilience dataset. All right. Now lines represent this file. Lines represent this file. The way we had in our pig, we had xyz equals load my file, right? Load my file. Similar to that we have here. Lines equals load this file sc.txt file. Okay. So it's very analogous to what does pig do. Okay. Pig also had exactly similar syntax. So this is how we create. So we created lines over here, and if you want to check what is the how many lines are there, we say count. Now it's going to run count on all the nodes and give you the summation of all of that. All right, here there are two tasks it has run. Okay, and right now it doesn't show me that the data. Okay, so right now everything is being run on Hadoop one, but in circumstances when the data keeps growing big, it will do it on multiple nodes. Right now, but there are two tasks which do that. Okay, so task one and task zero. Okay, and yeah, all right, great. Let me also have a look at what else is going on. Perfect, perfect. Now we are successfully able to create lines RDD, which basically contains a pointer to the data line over here. So any operation we do on this will be getting this. And you remember big.txt? Big.txt was basically a text file containing a lot of words, right? So slowly I'm moving towards our word count example, and this is the first step. Now, so Spark internally uses Hadoop and can also be run independent of Hadoop. Okay. So a better thing to do would be you guys also log on and you can, yeah, it did show that line count. If you see the last line here is, it says 1,28,457 is the line count. That is pretty fast, right? All right. All right. So now the next step, so we loaded the data. Now what do we do with this data? So there are two operations we talked about, transformation and action. So let's talk about what is transformation first of all. So transformation is something where you transform the data on the nodes where the data is existing. All right. So let me just take a step here. Right. So before we move on to transformation, let's understand how does it work. So first, there is something called resilience distributed dataset, which is nothing but a representation of the data spread across your cluster, right? Now there's something called Spark driver application. And Spark driver application is the one which launches your code. So whatever code you write for Spark, like load this file, do this, do that, all of that is launched from Spark driver application. Spark driver application sends work to all the nodes by the way of resilience distributed dataset. Okay, so a driver application, if says count, okay, it says count, then it sends the work to all the nodes containing the file and does the job. Okay, okay. Hello. Yeah, it seems the this thing is breaking. All right. I just need to understand what's going on with this. Hi. Okay, so is it still breaking, Vishal? Okay, so it is in happening intermittently. Okay, okay, all right. So let's try a little bit more, and then we'll see what can be done. And yeah. All right. So if it happens again, I'll try to reconnect. So let me know once it happens. Perfect. All right. So here we are talking about resilience dataset. So there is something called resilience dataset, which is a representation of the data spread across the whole cluster. Now there is something called Spark driver application. This is the application which you will be launching. This shell which we are talking about right now, the one which we have opened here, is basically the launcher of that application. So that is your driver application. All right. So now whenever we are doing an operation, it can be of transformation type, and a transformation is nothing but something that runs on the node containing the data, and they do the work in place, as in they read from resilience dataset, create a new resilience dataset for you. Okay, like for example, if we have to count line lengths. Okay, so line lengths will be basically, so we loaded lines, right? And we want to count line lengths. Okay, so what we can do is we call it line lengths equals lines is our previous resilience dataset RDD, and we say lines dot map, and then there is a idea called lambda. Lambda is nothing but anonymous function we are creating. Lambda is nothing but an anonymous function which we are creating in Python right now, and it will get a value. Okay, and in this we say k, and it will give you one particular line each time. Every map get one line. Okay, just like map reduce, here we get one line. Okay, and we say length of the line, and now we have a new data set called line lengths, and we can say, if we have to just we have got a new resilience data set containing line lengths is basically length of each line. So this is a big text file, and remember that we haven't done anything right now. But if you say line lengths dot take 10, Now it will do the job. Okay, now it will do the job. So it went to the input split called as this particular input, and then it ran the output. So it gave me these line lengths of this file. Okay, first the length of first number of characters in first 10 lines of this file. That's what I got. Okay, so now you notice two things. First, we did when we did a transformation called map, right? Nothing happened per se. Okay, so the real action happened when we said take. Okay, so which means whenever we are running a transformation, we are just describing what needs to be done. We are just describing what needs to be done. And when we call an action, then all of these transformation will be run. Just like your pig. You remember pig? So in pig, whenever we say dump or store, only then it used to do something. Okay? It used to do something only when we say dump or store. Before that, it will just keep on accepting the commands if the syntax is correct. So actual work happens like a batch in a single shot. Similarly here, that thing is little bit more granularized, as in there are multiple ways to start the process. And those multiple ways are called actions. Okay. All right. Now you have got transformations. Now transformation can be of many kinds. One of them is for each. Okay. One of them is for each. Okay. And second is the one is map is not like your normal map is something which basically converts one value into another. So for one value map gives another single value output. Okay, it cannot give multiple values for a value. Okay, now there is another kind of transformation basically means that it transforms the data in place. Okay, so whatever is the output of RDD is going to be stored in another RDD, another data set, and it is going to be in place on all the nodes. Okay, so map basically for each of the element in the data set, map takes a function as a parameter. Here also the map has taken a function as a parameter. If you see, this lambda is basically an anonymous function which we have passed here, saying that my function has an argument called line and it returns length of the line. All right, now so all of these take function as parameter. So basically map will take all of the elements of the dataset and apply this function on each of the element, and whatever is the output it is going to put it on another dataset. Okay, while a filter takes this function and in case and it executes this function on top of each of the element of the dataset, and in case these functions return true, then the value goes to the output. Otherwise, that value from dataset does not go to the output. Okay, so this function in the filter, so we pass the function as a parameter to the filter map or flat map or other there are more transformations for each, for example, right? So if you look at it closely, map is more like a for each of pig. Okay, map is more like a for each for pig. Now so everybody got the idea of a filter. In case there is a list of value, you only want to keep few values out of it, then you use for each. Okay, so let's just do it quickly. Now we have these line lengths, right? These line lengths, and out of these line lengths we just want to keep even number out of it, right? So we have line lengths, mhm, line lengths dot filter, and then I say lambda, and I'll get the number. Okay, the I'm sorry, let me disconnect and connect again. Let me disconnect and connect again, okay? Because the voice is breaking and that doesn't give a good experience.